Students, let's begin today's topic. But before beginning the topic, you know very well we would have 2 to 3 minute recapitulation session. See, you know very well that we have been starting our chapter number third, that is electrochemistry. You know, and we have done so many lectures. We have studied so many important topics in this particular chapter. Okay, we have studied what is electrochemistry, what are the applications of it, and in the last 2 3 classes we have done with the standard reduction potential, which is based on the electrochemical series. And on the basis of these standard reduction potential, we have calculated our EMF, that is electromotive force. है ना? And I hope very well that you know that EMF is something that is E naught cell. It needs to be calculated by E naught right minus E naught left, or we can say E naught reduction minus E naught oxidation. But one point that you should keep in your mind, that this E naught defines as standard reduction potential. So these was all the points we have done, we have completed. Now let's move to our next topic, the application of EMF. See class, in the very last lecture, we have just studied what is actual electrochemical series is. And one student, I just forgot the name, she has told very well that what is electrochemical series and what are the applications of EMF or electrochemical series. Okay, we have done with the help of electrochemical series, we can calculate the reactivity. Second, since my electrochemistry is totally dependent upon the redox reaction, so we have also calculated, we have also understood how to check out the oxidation or reduction comparison. That means which is more reductive, which is more strong reducing agent, which is weak oxidizing agent. These all topics we have done. And now, same in the manner, we are going to our third application, that is to check out whether hydrogen is removed from a reaction or not. So it just wants to say to us that suppose we are having any kind of reaction, any kind of reduction, and we need to calculate whether it can, whether on reacting metal, it would release hydrogen gas or not. So suppose we are having metal plus H positive, it would give to metal positive plus half H2. Only then we can say that yes, hydrogen gas is released out. That means my metal that has been dissolved into a solution of acid, suppose metal zinc, and it is dipped into 1 mole sulfuric. So 1%, would my zinc metal would release hydrogen gas or no? So the question is, according to this reaction, we modify it when we need to explain it a little bit. It tells me metal is releasing an electron and H positive is gaining that particular electron to become hydrogen gas. तो मतलब मेरा बिल्कुल क्लियर है यहाँ से, metal is at oxidation and hydrogen is at reduction. So in short, if my metal is if oxidation is taking place at my metal, then in this reaction we can say it would release a hydrogen gas, otherwise it would not. Okay, so this is something which is very important and very simple also. From this very simple equation that how H positive is converted into H2, we can easily say that yes, my metal is oxidizing, and hence due to oxidation our hydrogen is gaining the particular electron. Okay, so this is all I wanted to say to you. But now the point is, oxidation means, in the last class we have studied that the metals which are lying above the hydrogen, they have the negative reduction potential. What I have told you, that suppose my was something like this. Okay, magnesium, suppose this is hydrogen, then copper, silver and so on. So जो मेरा हाइड्रोजन से ऊपर वाले जितने भी मेटल्स हैं, they all have the negative reduction potential value. So in short, what can I say? If the value of reduction potential is negative, then it would replace the hydrogen as in a gas. Otherwise, it is not sufficient. It is not completely able to remove hydrogen gas. Am I clear, bache, or should I repeat it again? From this equation, we can say that if oxidation is taking place at metal, that means if metal is having negative reduction potential, this is known to be that metal would remove hydrogen gas. Because in the last class we have seen that oxidation is taking place only where the reduction potential is negative, है ना? और इसीलिए मैंने आपको इस रिएक्टिविटी सीरीज की हेल्प से भी समझाया है, the metals which are lying above the hydrogen, they have the maximum reactivity than hydrogen. So they have the maximum reactivity, they will replace the hydrogen, है ना? So this was the third application of my EMF or electrochemical series. I hope I'm clear with the topic. If still not, then please let me know whenever we have a doubt session after the ending of class. Okay. So very simple concept. Let's move to our next application. Now, last one application is okay. Just a second. Before going to the last application, let me show a simple numerical. We have given that zinc is dissolved in sulfuric acid and zinc is given E no value equals to minus 0.76 volt. So can I say that my zinc is removing the hydrogen from sulfuric acid? Yes or not? Yes, definitely. Because zinc is something which has negative reduction potential value, and we have done in our previous topic that if it has negative reduction potential value, that means it is something which can easily replace hydrogen, which can easily remove hydrogen gas, है ना? So this was a simple kind of example. Now lastly, we have left with only one application, that is to check out the spontaneity of reaction. What is spontaneity? Spontaneity, bache? Anyone knows it? See, is what we have studied in electrical cell also. Spontaneity means my reaction is going on its own. That means we do not need to provide any particular energy that yes, please reaction proceed. No, it has sufficient energy, it has sufficient pace that it can easily complete the reaction. So this is something, spontaneity means automatic, or spontaneity means without any efforts. So if we have to check out the spontaneity of reaction, that means we have to check out whether my reaction would take place or not. Okay, so spontaneity means whether reaction is taking place or not. This is known to be spontaneity. And we have studied that in electrochemical cell, there was spontaneous redox reaction. That's why they were taking place automatically. Suppose as zinc and copper sulfate, they're reacting. The reaction is taking place on its own due to reactivity, due to electrochemical series. So this is something which wants to describe us about the spontaneity of the reaction. Clear? Now the question is, we know spontaneity what is, but we have to calculate with the help of EMF whether my reaction is spontaneous or not, whether my reaction is taking place or not. So its simple answer is we would calculate our total EMF, that is E naught cell, which is equals to E naught right minus E naught left, or E naught reduction minus E naught oxidation. If E naught cell value comes to be positive, then my reaction is spontaneous. And if it comes to be negative, that means reaction is not as that. We have to just calculate the E naught cell. We have known the formula of E naught cell. We just need to calculate the value. If it comes to positive, that means yeah, we're okay. Our reaction is taking place on its own. If it comes to be negative, that means reaction cannot be proceeded. Okay, so this was something I wanted to explain. Now, let's see this particular concept with help of a simple question, which would clarify your concept more. Let's have a simple numerical. Okay, we have the question that's also in your NCERT textbook. The question is something. Can a solution of 1 molar copper sulfate be stored in a vessel made of nickel? That means we have been asked कि हमारे पास भाई copper sulfate है and we have to place it in nickel vessel. That means only nickel is provided but copper sulfate is provided. है ना? And we have been asked whether copper sulfate solution can be stored in nickel vessel. Okay, so let's see, does it happen or not? And also, bache, I have told you that you do not need to remember these reduction potential because you would be provided each and every equation. This is minus 0.25 volt. I'm not wrong. Yes. And copper 2 positive, it comes to be 0.34 volt. Okay. Okay. Now, we have been provided with the two equations and we have taken nickel solution and copper sulfate. That means we can write nickel plus copper sulfate is converting to nickel sulfate plus copper. यही तो है. We have just been provided with nickel and copper sulfate. That means copper is present in the form of copper 2 positive because sulfate 2 negative ion is nothing. It just helps us to maintain the we can say stability or we can say to maintain the neutrality. है ना? So nickel plus copper 2 positive is converting to nickel 2 positive plus copper. So from this equation, can I say my nickel is something which is taking place oxidation and my copper 2 positive is something which is taking place reduction? Clear? So my first step has been cleared. Whenever we get an equation, our first term is to calculate which is reduction, which is oxidation, because that is half of our answer. If we have done so much, we can easily calculate the E naught cell value, which is equals to E naught reduction minus E naught oxidation. What is E naught reduction? That means copper 2 positive, this is 0.34 minus E naught oxidation is given to be minus 0.25. So minus minus would become positive and the value would be equal to something 0.59 volt. But we do not have to care with the measurement. We have concern our topic only with the sign. The sign is positive. That means yes, the reaction is taking place. So if the reaction is taking place, if the reaction is spontaneous, can we place our copper sulfate into nickel vessel? No, definitely not. Because if my reaction is taking place, copper sulfate would react with the nickel, and what would happen? Copper sulfate would be spoiled out. We have to out the includes in your board exam. Please focus this. First, check out the spontaneity, or we can say whether reaction take or place. Second one, which can be placed in a vessel. In your board exam, you will see either of these questions. The question is same, but its method of representation is two different ways. Okay, so clear with the topic, concentrate this topic, that these questions are very important. Definitely either of 1 marks or 2 marks you will see in board exam, and not only on board exam, for your competitive exams too. These questions are super important. Application of EMF cell and EMF series, this is very important, bache, for your competitive exams also. Okay, so do not miss the topic, do not miss a single application also. Okay, very important. As I have shown you that copper sulfate cannot be stored in nickel, same as it is, question could become like copper sulfate can be stored in silver vessel or not. You will get the value of both standard reduction potential of copper as well as silver, and definitely you can calculate the inert cell value and you will come to know. Okay, one more thing bache, I'm repeating again and again, I'm repeating in the same question also. You have been provided with the standard reduction potential, है ना, और मैंने आपको बात कई बारी बोली है कि whenever we calculate value, we have to take into consideration this E reduction, and this E naught oxidation defines the standard reduction potential of the reaction at which reduction is taking place, and standard reduction potential of the reaction at which oxidation taking place. Okay, so first of all, have a look whether it is given as standard reduction potential or not. Okay, if it is mentioned that this is standard reduction potential, then you have to do nothing. But if the question would become like E naught nickel to nickel 2 positive equals to minus 0.25 volt. Nickel 2 positive to nickel, that means it's gaining 2 electrons. That means it is standard reduction potential, and it seems to be oxidation potential. So what would you do? You would simply do standard reduction potential equals to minus 0.25, that is positive 0.25. Okay, so you have to nothing do, you have to just change the sign, and this sign important very well. This sign matters in the numerical session, because on the basis of sign the answer would be changed, and definitely the wrong answer and the right answer would come in your MCQs, and you would tick which one is the wrong, है ना? So please check out first of all whether standard reduction potential is given to us or not, because only on the basis of that you can calculate these all numericals. Okay, bache? So this was the point I wanted to explain to you. Now we have completed all our applications of EMF also, as well as electrochemical series. Now we're going to move with our next topic, that is Nernst equation. We will start our next topic that is Nernst equation within a 1 minute. If there is any kind of doubt or query, please write it out. We will see that in last session. Okay, so the next topic is Nernst equation. We would just simply today start the introduction of Nernst equation, because that is very lengthy and it couldn't be completed, but we would complete its fun part. Okay. Okay, what is Nernst equation? What it wants to convey to us? All right, but you see, what we have done till now, we have seen that there is something known to be E naught, zinc 2 positive. So this E naught means something which is standard. It is standardized. Standard means it is following all the standard terms and conditions of a reaction. Have you heard about STP? Standard temperature pressure. Anyone have anybody heard about standard temperature pressure? It is something, it is any kind of reaction condition which convey to us that our temperature and pressure is of standard value. And what does standard value means? If I'm talking about my temperature, the standard temperature is equals to 298 Kelvin, and my standard pressure is equals to 1 bar. Same as it is, the STP wants to say not only temperature and pressure, we have the standard value of concentration also. Please keep that in your mind, that STP is not only something which wants to say that if I'm talking about E naught, this is standard electrode potential. That means it is at standard temperature, standard pressure, as well as standard concentration, known to be 1 molar. Okay, Now we have completed all these three equations. Now the point arises कि we have an E note only. We have calculated in EMF, we have calculated in electrochemical cell, all in those equations, all these applications, we have just taken the E note. But the point is, what would happen if we have to calculate the E value, the electrode potential at some different concentration? क्वेश्चन समझ में आ रहा है मेरा कि हमारे पास सब चीजें sufficiently given है, but what would happen if we have to calculate only E rather than E note? Suppose मैं सेम इसी क्वेश्चन की बात कर रही हूँ. We have been provided with E note. How to calculate E? We have been provided that suppose the concentration is now molar. It's standard. Definitely query. A science came named Nernst, and he gave us equation by the help of which we can calculate our E value. Okay, so Nernst equation is not, it's just a mathematical equation, it's just a mathematical formula on the basis of which you can calculate the electrode potential at any concentration. Am I clear? So that's this is it. Let me write the equation and we would proceed from this reaction in tomorrow's class. Okay. So the Nernst equation, E equals to E naught minus RT over NF ln 1 over M. And let me denote what M represents, what everyone represents over here. Okay. Now, first of all, suppose my reaction is converting from Mn positive, that means oxidation is place and it is taking N electron. ये मेरी reaction है, ये मेरी final reaction है. Different equation. First let me Nernst equation C equals to E naught minus RT over NF natural logarithm defined by initial constant. Am I clear or not? It's just saying to us that it is something which is considered by the initial concentration. At any concentration, E naught is number of. Sir, have it? Sir, is time not sufficient now? Okay, just let's complete this final term within 2-3 minutes. F is known to be Faraday's constant. All right, class. We have been provided with E naught, R, T, N, F, Ln, that is natural logarithm. And that is the final product, and M is the initial. This is known to be Nernst equation. Now, the question is, if we have been provided with M equals to 1, my equation would be E equals to E naught minus RT over NF ln 1 over Mn positive. Clear? One more thing, if we have to convert this natural logarithm into logarithm 10, I hope medical students also have read this so much that whenever we have to convert, it would convert into that's it. Okay, this E equals to E naught minus 2.303 RT divided by NF logarithm. This logarithm is of the base value 10, whereas this is natural logarithm. Okay, so this was it. All I wanted to say about the Nernst equation. And one more thing I would like to say, that if we put the equation R, T, N, and F, we would come to know if I put my R equals to 298 Kelvin, we have been provided, sorry, R is not 2. It's 8.314 joule per Kelvin per mole. You have studied this in your 11th class. This is my gas constant. T equals to 298 Kelvin. F is Faraday, that is 96500. If we put all this value, my E would become E naught minus 0.0591 divided by N log 1 over Mn positive. Am I clear, bache, or not? Have you got? I have just put all the equation, I have just put all the constant, and my equation now has become to E equals to E naught minus 0.0591 divided by N. This is known to be Nernst equation. All right. So this was all I wanted to explain to you. Now, if there is any kind of doubt or query, please let me know. But I just want to say my Nernst equation is not completed yet. It is just the first step, or we can say it is just a first part of Nernst equation, in which we have seen that only half reaction is taking place. But what would happen if there is two metals? What would happen if the two reaction is taking place? That we would see in tomorrow's class. Okay. So this was it all, students. Now please let me know if